Back in 2017, a group of researchers published a paper with a pretty simple title. But that paper didn't just nudge AI forward a little bit. It completely rewrote the rulebook for how machines understand language. It's the reason we have the incredible AI tools we use every single day. So in this explainer, we're going to break down that revolutionary paper, Attention is All You Need.
Okay, let's just start right here with this opening line from the paper's abstract. They come out swinging, making this incredibly bold claim. They're not just improving the old methods, they're throwing them out entirely. We're talking about recurrence and convolutions, the bedrock of language AI at the time. This wasn't a tweak. This was them saying, we found a better way.
Now, to really appreciate just how groundbreaking this was, we first have to understand the huge wall that AI research had run into. It was a problem of speed, of memory, of just going in a straight line. They called it the sequential bottleneck.
So before this paper, the TOM models were things like recurrent neural networks, or RNNs. And as the paper says, these models had an inherently sequential nature. Just think about how you read a sentence. You process one word, then the next, then the next. That's exactly how these models worked. They were forced to go in order, one step at a time.
And you can imagine, this one word at a time approach was a massive problem. First off, it was incredibly slow. You couldn't just process a whole document at once. But even worse was the memory issue. For a really long sentence, by the time the model got to the end, it might have totally forgotten what the beginning was even about. So the challenge was obvious. How do you break out of this slow, step-by-step prison?
So, how did they propose to solve this? Well, their solution wasn't just a clever new feature. It was a whole new way of looking at the problem. And the secret, as it turns out, was hiding in plain sight, right in the title of their paper.
They came up with this mechanism called self-attention. Here's the core idea. Instead of slogging through words one by one, self-attention lets the model look at the entire sentence all at once. It weighs the importance of every single word against every other word. So it can instantly figure out that in the sentence, the cat sat on the mat, the word sat is most connected to cat and mat, no matter how far apart they are.
Here's a good way to think about it. The old way, the RNN, is like one person reading a sentence through a tiny tube, only seeing one word at a time. Self-attention, on the other hand, is like a whole team of analysts in a room with the entire sentence laid out on a giant table. Instantly, they can all point and draw connections between any two words, no matter where they are. This ability to see the whole picture at once, well, that's the key.
Now, an idea this radical needed a brand new machine to run it. So they didn't just modify the old models. They built a totally new architecture from scratch, and they gave it a powerful name, the Transformer.
The Transformer has two main parts: an encoder that reads the input text, and a decoder that generates the output. But the truly revolutionary part is what's inside. It's built on layers that completely ditch the old way of doing things. You see it right there at the bottom. No recurrence, no convolutions. They totally ripped out the old engine and built this thing to run purely on attention.
And they didn't just use one of these attention mechanisms. Oh no, they used several in parallel. They call it multi-head attention. Think of it as upgrading that team of analysts. Now, instead of one team, you have multiple specialized teams. One might be focused on grammar, another might be tracking the meaning of words, and a third is figuring out pronoun relationships. Together, they build this incredibly rich, multi-layered understanding of the sentence.
So this all sounds great in theory, but why was this new attention-based model actually so much better than what came before? The paper breaks it down to a few key factors that are just undeniable. Take a look at this table. It's straight from the paper. Now, don't worry about all the crazy notation. Just focus on that column called sequential operations. For the old recurrent models, it says O of n. That means the longer the sentence, the more steps it takes. It gets slower. But for self-attention, look at that. It's O of 1, a constant. That's the game changer right there. It means the model needs just one single step to connect the first word of a sentence to the last, no matter how long the sentence is.
So why does that O of 1 matter so much? One word: parallelization. For the first time, you could unleash the full power of modern computer hardware on the problem. Instead of being forced to go word by word, you could process huge chunks of text all at the same time. This didn't just speed things up a bit, it made it possible to train models on datasets bigger than anyone had ever dreamed of before.
Of course, a great theory is one thing, but you have to prove it works. So the authors took their new transformer architecture and put it up against the notoriously difficult task, machine translation. And here are the results. These are BLEU scores, which is just a fancy way of grading translation quality. Higher is better. The models at the top, those were the state-of-the-art champions of the day. Really complex systems. And then comes the transformer.
The base model just waltzes in and beats them. The big version, it doesn't just win, it sets a whole new record.
Let's just focus on that one number for a second. An improvement of over 2.0 BLU points on the English to German translation task. Now, in the world of machine translation, that is not just an improvement. That is a massive, record-shattering leap forward. It was an absolute mic drop.
And here's the real kicker. It wasn't just better, it was also way faster and more efficient. Their best model trained in just 3.5 days on 8 GPUs. That was a fraction of the time and computational cost of the older models it had just beaten. So it was better, faster, and cheaper. It was the total package.
But the shockwaves from this paper went far beyond just making better translators. This was the moment that laid the foundation for a complete revolution in artificial intelligence.
Let's be really clear about this. Almost every major AI language model you hear about today, GPT, BERT, all of them, they are all descendants of the transformer. They're built on this architecture. By solving that parallelization problem, this paper threw open the doors to the era of large language models, kicking off the AI world we live in right now. It proved that a simpler, more elegant idea could be far more powerful.
In the end, this paper proved that a single, powerful idea, letting a model weigh the importance of all its inputs at once, was way more effective than years of complicated engineering. It really leaves you with a fascinating question to think about. If attention was the simple idea that changed everything in 2017, what's the next one that's just waiting to be discovered?